We'll now discuss modular arithmetic, how to do it, and what it means for two things to be equal in modular arithmetic. When we're dealing with modular arithmetic, we don't actually have equals, instead we have congruent. And we say A is congruent to B, modulo M, if and only if M divides A minus B. And in this case, we write equivalent as like a triple equals, B mod M. I'll look at a couple of examples of how to show things are congruent using this method, and then we'll talk about an alternative method to perform and see if things are congruent. My first example, I want to know is 23 congruent to 5 mod 6. The first thing I need to do is then subtract 23 minus 5 to get 18. And then I want to know, does 6 divide 18? And yes, it does. Therefore, yes, these numbers are congruent modulo 6. Another example. Once again, we can do 18 minus 26, and this gives us negative 8. And then we can see that 6 actually does not go into negative 8 evenly. Therefore, no, these are not congruent. We'll now look at an alternative way to show things are congruent. We'll suppose A and B are integers and M is a positive integer. In that case, A is congruent to B mod M if and only if A mod M is equal to B mod M. Therefore, we actually do the modular operation on both numbers and then see if they're equal. Going back to our previous examples, 23 mod 6 wants to know what is the remainder when we divide 23 by 6. Well, 6 goes into 23 3 times with a remainder of 5. In addition, we know that 5 mod 6 is equal to 5. Therefore, yes, these are congruent since 5 is equal to 5. For our other example, if we did 18 mod 6, well, in this case, we know that 6 can go into 18 evenly, so we have 0 remainder. 26 mod 6, well, 6 goes into 26 4 times with a remainder of 2. And since 0 is not equal to 2, these are not congruent. We'll now actually look at performing arithmetic operations in modulo M. For this, if A is congruent to B mod M and C is congruent to D mod M, then A plus C is congruent to B plus D mod M, and AC is congruent to BD mod M. Essentially what this says is if we want to do either addition or multiplication in modulo M, we can either do our modular operation and then add or multiply, or we can add and multiply and then do our modular operation. So the order here doesn't matter. As an example, I have 12 plus 16 mod 5, and we'll do this two different ways. The first way is to realize that 12 mod 5, 12 divided by 2, or 12 divided by 5 has a remainder of 2, and 16 divided by 5 has a remainder of 1. Therefore, this is equivalent to 3 mod 5. The other way would be simply to add and realize that 12 plus 16 mod 5 is equal to 28 mod 5. And when I divide 28 by 5, I get a remainder of 3. So either way I get 3. It's really just a matter on if you want to perform your modular operation first or second. As in a second example, let's multiply 12 times 16, mod 5. In this case, we may not want to actually multiply 12 times 16 first because that can be kind of more difficult since we're dealing with bigger numbers. However, we know 12 mod 5 is 2, and 16 mod 5 is 1, and 2 times 1 is 2. Therefore, our answer is 2 mod 5. We do have some shortcut notation. For example, A with a plus sub m, B, means A plus B mod m. In addition, if I multiply and once again put the sub m, this means A times B mod m. These are just abbreviations for this modular arithmetic. As an example, 5 plus 9, 7. This means 5 plus 7 mod 9. So first we're going to add 5 plus 7 to get 12 mod 9. And I know that 9 can go into 12 once with a remainder of 3. Therefore, 5 plus 7 mod 9 is 3 mod 9. Another example, if we do multiplication, we know that 5 times 7 is 35, and then we know that this is mod 9. 35 divided by 9 has a remainder of 8. Therefore, our answer is finally 8 mod 9.